Hello and welcome back to another edition of How to Do Math with your host, Alex Guerin. Today we have another polynomial. Our new friend h of x equals 25x to the fourth minus 40x to the third minus 19x to the second minus 2x. Did I get it correct? I did. All right. So we do get this lovely given that x equals 2 is 0. So that's very nice. But first, before we start factoring, we're going to want to grab the end behavior from the standard form. So we can see that the leading coefficient, 25, is positive, which means that as x is going to infinity, y is also going to be going to infinity. And the degree of this polynomial is 4, which is an even number, meaning that the end behavior is going to be the same on both sides. So then we get, as x going to negative infinity, y is going to be going to positive infinity on that side too. So, yay, math. And so now we go over to factoring this guy. And if we see it here, we can't take any of the coefficients out, but we can take out this x first of all. So we take this out and we get 25x to the third minus 40x to the second minus 19x minus 2. Yeah, and now since we know that x equals 2 is a 0, that's going to mean that we can use synthetic division to divide the rest of this guy by 2. So putting this x off to the side for now, we're going to use our synthetic division. I'm going to pop in the coefficients over here. And since it's divisible, we know that it's going to even out. So do the division. We bring down the 25, multiply by 2 is 50, add these and we get 10, times 2 is 20, minus 19 is normal 1, times 2 is 2. If we add these up, we get 0. So it went in correctly. So now these are going to be our new coefficients. So we have our x, and then we have times our x minus 2, which is going to give us the 0 of x equals 2. And then times 25x to the second plus 10x plus 1. And now we have a quadratic, so we can factor this guy. I don't know how it's going to erase this because we have our guys already. So we're going to take 25 times 1 up here, and we're going to put 10 over here. And our factors are going to be, 5 and 5. Because 5 times 5 equals 25, and 5 plus 5 equals 10. So, through that in there, we're going to get our x minus 2, and then we have 25x to the second, plus 5x plus 5x plus 1, which is going to end up being 5x, 5. Oh my god. 5x plus 1. But would you look at that? I'm messing myself up with this, man. I don't know how these parentheses are doing, but then we're going to take the 1 out of this because we already got it here, giving us our grand final factored form of x times x minus 2 times 5x plus 1 squared. Ta-da! We have done the math, guys. Math is going. And now we can use this factored form to find our zeros and our intercepts. So the degree is 4, we have 4 zeros, and luckily they're all right in here. So if we set x equal to 0, that is going to mean x is 0, and then we have x equals 2, and then if we do this out, we get x equals negative 1/5, and that is going to be of multiplicity 2. Throw that under there in parentheses. All right. And now we use our zeros to find our x-intercepts because all of these are real zeros. So they're all going to be x-intercepts. So we have them at 0, 0, at 2, 0, and then 1 at 1/5, negative 1/5, 0. And as for our y-intercepts, again, we don't need to do any math to find those because it's going to, again, because in the last one we had the same situation where the origin is going to be our y-intercept as well as an x-intercept. So now with all this information, we can go and find our graph. So I'm going to put the factored form a little higher so we can keep that there. And then we're going to draw our quadratic plane. That is an ugly looking quadratic plane. That's a little bit better. So first we're going to graph all the points that we have. So we have 0, 0, we have 2, 0, and we have negative 1/5, 0 that I'm going to put over here. And if we look at our end behavior, we have y going to positive infinity on both sides. So it's going to be doing something like that. And now we have to draw the rest of the lines. So at 0 and at 2, these are zeros of multiplicity 1. So the line is going to pass through these guys. But at negative 1/5, that's a 0 of multiplicity 2. So instead what's going to happen, instead of passing through, this guy's going to bounce off. So it's going to touch the x-axis but not go below. And it's going to bounce back off, going to negative infinity for the x. And this is nice. So then, so now if we want to find our domain and range, we know that x is going on forever and ever in both directions. So our range is going to be written as x is the element of negative infinity to infinity. But as for our y, we really don't know how far down this goes. We just know it goes down here. So as far as our range, we know it goes to infinity, but we can't tell how it goes for negative infinity. So as far as y goes, we just gotta say that there's not enough. Oh my god. We just have to say that there's not enough information. I'm not going to attempt to write it anymore. And that has been How to Do Math with Alex Garian. We've learned many things about this polynomial today. I hope you guys enjoyed. It didn't turn off.